Just a quick update on that 1 kilowatt inverter that had a bad transformer. This X right here is a transformer that's bad. So what we have is 4 transformers in series instead of 5, and so that drops potential voltage 20%. This thing is rated to go up to 140 volts, and so if you subtract 20%, that means that it shouldn't work over 115 volts, but you know, for some reason it does. So right now I got about 240 watts going into it and 184 watts coming out. This is a really nice meter. This is watt meters from 20 to 20 kilohertz, so it can measure any distortion that's on the power line. So that's what you really want to see. And as you can see, it's 121 volts, and there's the volts and the amps going in. But here's the shocker. This green line is the sine wave. That's the AC line, and the yellow line is the current. And as you can see, they call this a pure sine wave inverter, but it's not. It's just bumping at the peaks, and a lot of them do that. Nothing wrong with it. It puts power onto the line, but as you can see, it's probably a little bit noisy. And I thought by varying the voltage a little bit, you know, going down to 110 or going up to 129, that things would change, that it might flat top or something, but it doesn't. So this is the inverter right here. There's a big hole in the circuit board. I had to take a couple wires and jumper them over. So it just shows that you know, even if you have some extreme damage, you can still make an inverter somewhat useful. This is a 1000 watt inverter. It's probably good for 600 watts now. I have an application where I only need to produce 300 watts at my camp, and this will work fine. It's better than having to scrap the whole unit. So that's what's happening. Just look at that waveform again. Woo! It ain't pretty, but it's putting out power. Thanks for watching.